Let's do a problem from your lab assignment, section 11.4. This is number 2. Determine whether the series converges or diverges. You have a series n going from 1 to infinity of 12n squared plus minus 4 divided by n to the 4th plus 3. Alright, so there's a couple of comparison tests, actually 3, but the limit comparison test would work here also, but I think they're going to choose the first comparison test. And so a good way to determine what to compare it to is to take a look at the highest, for polynomials, is to take a look at the highest term in the numerator and the highest term in the denominator. So this is 12n squared over n to the 4th if you just focus on those two terms as a fraction and then cancel out an n squared, and then you would have an n squared in the bottom and then no more n's on top. So a good function or a good series to compare it to is 12 over n squared. And one thing to note is that 1 over n squared, if you take the 12 out, is a p series, and with p bigger than 1, you're going to converge. And so this is a convergent series. So now that we know it's a convergent series, so that's like b sub n is a convergent series, we're going to want the a sub n's to be less than that. So that's our key. So let's see how this is going to work out. So the original series is going to be, well, is it going to be bigger, greater than, or less than or equal to this? So it looks like here they took a 4 out. They took a negative 4 out. So negative 4 makes this smaller than if it didn't have a minus 4. So this is going to be less than. Since the numerator of the second is less than the numerator, oops, is that right? So the numerator of the second, this is a second, is going to be greater than, because here you're subtracting out. So the numerator of the second is greater than the numerator of the first. So there's some tricky language here, so you have to be really careful and meticulous about what they're asking for. Alright, now we've broken it down to this. This is now going to be less than or greater than this. So it looks like the denominator here is bigger than the denominator here. So if you have a larger denominator, that's usually going to be a lesser fraction, since the denominator of the second is less than the denominator of the first. Because in the first one you're adding 3, in the second one you're adding nothing, so it's less than. Now this is equal to 12 over n squared, which is what we kind of looked at in the beginning. And so now, all in all, we've shown that the original series is less than the series that we are looking at. So the second series here converges, and then we have something that adds less terms. And so because this thing converges and this thing adds less terms, then the original problem is also going to converge. So like I said, it's like the first property over here, where we have let's see, let's draw a little highlighter. So it's like bn, it's like the 12 over n squared, which we know converges, and then bn is bigger than a sub n. So a sub n is less than b sub n in this case, a sub n less than b sub n. And so the original series A is also convergent. Okay, let's submit. And that's good. Okay, I hope that helps.